Do you remember replacement notation? Yes, that's the one where you figure out what the x is and you throw it in and you replace all the other x's. Same thing goes here. There's something right for math 10C. This means wherever you see an x in the original equation, you're going to, listen to this word, ready? Replace the x by 2x. So you're actually substituting in a 2x wherever you see an x. What does this mean? Watch. Y equals 2, that's blank squared minus 2 blank minus 3. Wherever the blanks were, because remember, this has to go in where every x was. It's a replacement. So guess what? That's now 2x. That here is now 2x. Ah, lovely. I see it. I see it. So y then becomes, well, take this whole thing and square it. So that becomes 4x squared. Take this guy here, distribute, right? That's going to give you minus 4x. And poor little lone 3 still stays there because it doesn't change. Now, what's really cool about this, think about how this now compares to the original. Well, that tells you how it compares right there. Whereas before, we used to look at an equation like this and we'd say, oh, yeah, that looks completely different than this one. Now we know by substituting the 2x in there, this is a horizontal stretch, right, of 1/2. Isn't that interesting, right? Cool. Okay, so let's go on to the next round of stretches. Here's one where the 3 is in front. Oh, well, let's just take the original f of x, just multiply by 3. Oh, okay. What was the original f of x? Let's go back here. It was x squared minus 2x minus 3. Okay, so x squared minus 2x minus 3. That's the original f of x. And all I'm going to do is just put a 3 in front of it. Oh, okay. All it means to do now is just distribute. Oh, well, this is fun. Here we go. This gives me 3x squared minus 6x minus 9. Done. And what does this mean? This means, look at this, we have a vertical stretch by factor 3. Oh, interesting. Well, yeah, well, look, if this vertical, here's our vertical y-intercept, and it's stretched by 3. It now becomes minus 9. Oh, well, that's just too cool. Let's look at the last one. I got one more for you here. Take a look at this guy. Ah, okay. So let's get rid of this half, right? How do we get rid of this half? Well, divide by half or multiply both sides by 2. Okay, that cancels out, leaving us y equals 2. Oh, there's a minus here. Minus 2 f of x's. Okay, what does that mean? Okay, all that means is, of course, we've got a vertical stretch, and we're reflecting across the x-axis. Simple. All right, so let's take the negative 2. There it is. Original equation, which was x squared minus 2x minus 3. Okay, and let's distribute. Bada-boom, bada-boom, bada-boom. So this becomes minus 2x squared plus 4x plus 6. Because think about it. This was our original y-intercept. We're flipping it to making it a positive y-intercept, which is what we've got here now. And scale factor times 2. Look at that. Isn't that cool how everything kind of comes around, right? All of these vertical and horizontal transformations are all coming around now. Makes sense to me.